My name's Greg. By all standards, I'm a veteran product person at Kentik. I've been here early on. My main goal here is that people go from casually using Kentik to people opening Kentik in the morning and Kentik telling them what to do during the day. But that's a product fantasy. We'll get there soon enough. Just a little bit about me quickly. As obvious, I'm a recovering networkaholic. I've built a variety of networks throughout the early years of my career, whether they be internet service providers, internet exchanges, content delivery networks, a few of them actually, large content platforms, and I've a shift to the dark side and I do product now. I'm going to talk a little bit of a topic that's, that I love talking about, so don't hesitate to tell me to slow me down because I get a little bit emotional when I talk about it. And here we go. So I'm going to talk about interconnection and metrics for service provider networks. So why do networks interconnect? And it's like a very simple question with a not so simple answer, obviously. But we can always boil it down to three elements. We interconnect for cost, we interconnect for performance, and the third one that I'm displaying in small font because it won't matter much today is path diversity and resiliency. Here's the thing though, none of these is a native attribute of network data or not a readable native attribute of standard network visibility systems, whether it be Flow or SNMP. So we believe at Kentik that there's something we can do about this. And so just in case people are not entirely familiar with the vernacular and all the naming here, I'm just going to do a quick refresher. You've got your eyeball network serving internet subscribers, users, and it has an upstream because it needs to go outside of its network to fetch in content over the internet. So usually it goes through a transit provider, and the transit provider sees packets coming in and lets them out towards the right direction. They transit traffic from content to subscriber and so on and so forth. And at the other end, you get a content network. Can get a little bit more complicated. In order to change these cost and performance variables, networks can interconnect directly, meaning if I'm an ISP, I might find it interesting to directly connect to a content network, and I got multiple ways to do so. And if I did, I would bypass my transit provider for this specific content provider destination or source. And so I could use, and I draw the money flow. So I pay, the ISP eyeball pays the transit provider for traffic that, the maximum of traffic that gets in or out of their network. I can decide to interconnect on a paid basis, so we'll call that a paid PNI, private network interconnect, which is basically drawing a cable, fiber, between the ISP network and the content network in that case. Or we could get a settlement-free peering agreement by which we wouldn't pay each other, and so no money flow here. Or I could decide to hit multiple birds with the same stone, connect myself to a peering fabric, and then peer with all the participants of that peering fabric. In this case, we would call that a public peering. Now that we've clarified that, let me go and talk a little bit about the way people used to do interconnection decisions. And so most of the time, it's not real time, meaning I need data, I crunch it, go get a coffee, grow a coffee tree, and basically get my data much later, which means you can't really be reactive or proactive when it comes to that. It's not self-serve. Sometimes the people that need that data, the capacity planners, the people that purchase connectivity for the network, they need that data, but they need to go through an engineer, and happy times. It often involves wrangling data across spreadsheets. You take data from the network, you add business logic from the accountant or the connectivity people, and you mix all of that together and you get a guesstimate. What that means also is that it's pretty labor intensive. Also, path visibility we all know in network data is tricky at high scale. Most of the time, you'd only get data from the edge because you need to get the data from all routers and then manually munch it together. So rarely do you have an end-to-end view of how traffic flows through your network. Again, it's often as a reaction and not as a plan or a preemptive action. And most of all that stems from the fact that that information, that data, that logic is segmented across multiple amount of silos within your own company if you're a network. And so rightfully, you have to ask yourself, what does my network data get me today? Well, you see source and destination AS numbers. Okay, tells me what the source of the traffic is or what the destination is. That's useful. Some basic amount of GeoIP. And bear in mind, the more the scale increases, the more these simple basic things are difficult to gather cohesively. You may get router or site breakdowns if you've matched your network visibility data with your own DKIMs or whatever tool you use for inventory, and you've got some rudimentary amount of AS path information. And so obviously, it's not enough, and I'll show why. The first step is to bake the business logic in that network data. As you've seen, one of the things that we at Kentik do pretty well is that we take your inputs, we take inputs from other various sources, whether it is SNMP, whether it is NetFlow data, whether it is DNS data, we'll talk about that later, radius data, and we enrich all of this together. And so the idea to bake the business logic is you build that logic once, right? You try and make the logic configuration as easy and understandable as possible. And in that case, we'll rely on SNMP data. And then we're going to use that information for that business logic to describe transit, to describe peering and such throughout the entire Kentik platform, meaning that any flow that comes in has this information in it, so we can leverage it in any other workflows that I actually presented earlier. And also, you kind of want to make it dynamic, right? Because the day someone adds a new card with new ports on it and connects new networks to it, you need your network to understand that, convey the information, in that case via SNMP, and for all that business logic to be updated live, right? And so what we care about in all that I'm going to talk about is very few things. Connectivity types. By that I mean, is it a transit interface? Is it peering? Is it paid peering? Are these embedded caches? And I'll talk a little bit more about that after. What is the directionality? You notice that when you use the data explorer side of Kentik, you want to be able to very quickly say, I want to see all of my inbound traffic. How do you do that? Well, what you do in that case is you define with interfaces whether or not they're facing the outside or the inside of your network. Pretty simple. And transit, peering, and all of these are external interfaces, so you need a way to do that simply. And eventually, you can also add provider information. What's the provider behind that interface? And so I'm going to switch and show you how we do this, if I ever can. Here we go.
And Greg, it's about 30 minutes left for both sections.
All right. And so this is a rules engine by which I'm going to be able to say, look at these interface description. If I match this, so this is a regex, but it could be a simple match. In that case, tag them as an embedded cache. And this way, I'm going to be able to see that here. That's not what I was looking for. Sorry about that. These green checked interface are going to be detected as Google global cache interfaces. That means I have caches on my network that are Google caches, and that'll be very helpful to me in the future. And I've got something that tells me how far I am classifying all of that, so that the entire Kentik platform can leverage that and color flows accordingly. And so that's the first step here. Now let's go back here And so we said cost, we said performance. For these two dimensions, there's multiple questions that are important to answer that you can't literally answer with standard network visibility tools out there. Like, for instance, for a carrier or transit provider, how do I compute the ROI on a per customer basis? How do I know how far I can go in renegotiating a contract and discounting the previous rate that I was offering? It's a significant competitive advantage to be able to do that on the fly, isn't it? For a residential ISP, how much do my subscriber cost me? Am I pricing my plans right? How much does a given OTT service cost me? What's the performance for that given OTT service? And for an enterprise and content provider, is how much does every one of my users cost me, period. And so we're gonna take a look at how Kentik offers to track costs across providers. And so a very simple 3 steps process here. The same way that I talked about the interface classification engine, the first step is describe your contracts. Fully articulate how your connectivity gets billed to you for each one provider in the most string-complete way, but yet easy possible. Then track using SNMP, because Kentik receives your SNMP data, so you can track according to actual data, not sample data, which when it comes to cost is pretty useful. And then plan, because once you've entered that cost data, once you've entered that interface classification data, this logic is available to the rest of the workflows within Kentik, and you can leverage it at any time in any of the workflows that we have. So I'll show you a quick demo on that. Nope. And so within the same task-oriented menu that Akshay showed previously, I'm going to go to the connectivity cost. And I'm going to get an instant view on how much traffic is costing me. And I can get breakdowns for all of my providers. I can track my cost, but I can describe things. So I'm going to add a provider here. And let's say I'm going to add Equinix. And this is an internet exchange, because I'm going to pay for a monthly fee for ports. So I'm going to add that guy. Now, my contract with Equinix, I might pay a specific price for a specific port in Frankfurt, but I may pay another price for a port in San Jose. And so I need to be able to describe that. So I'm going to add cost groups. And so I'm going to add a cost group. Then I'm going to call Equinix Frankfurt. I'm going to say that it's a flat rate. I'm going to pay $100 for 10 gigs.
I'll take some.
You got it. And then I'm going to associate interfaces with them, with that cost group. Maybe it says IX here. I'm going to add these guys here to the cost group. And now from now on, the SNMP engine is going to know that this is associated to Equinix as a provider and for Frankfurt specific. And now I'm going to do the same for, say, Equinix San Jose. And I'm going to take a flat rate, but this also works if you use a transit provider and you have committed rates, 95th percentile built, and even if you have tiered layers of pricing, it's that price until 10 gig, and then it's that price over 10 gig to 20 gig, and so on and so forth. So you can fully describe that. So I'm not going to insist on that, but basically your costs turn into the configuration engine, and although not entirely available right now in every other module, you can have a quick view that allows you to plan cohesively and keep an eye on your cost as a global outlook that you can check on often. You seem to have a question?
Yeah, I think I saw earlier. So are you able to like track like egress costs for public cloud providers, right? So in a lot of cases, you're charged per gigabyte of traffic for your egress traffic out of cloud providers. Are you able to kind of do the math?
So we'll take the max of the 95th.
Okay.
And so usually it's kind of mostly unidirectional. The other channel is going to be pretty low. You're either going to push a lot or receive a lot for a specific use. So it'd be fine most of the time. But in the case where you specifically want to select it, it's a good feature that I'm going to keep in my mind.
But if you had both data sources, like the cost
Yep.
and
Yep.
the
That's a very
actual
good
traffic, okay.
Thanks for noting that.
There are some other roadmap things like projecting backbone cost for international backbones, not just the exit. This is the first set of workflows, and then, try Kentik, submit, get feedback, and Greg will
And you could even look at the same thing with like LTE cellular connections with SD-WAN.
Yeah, anything that's a place or a slice across the network, whether it's, again, BGP communities or IP addresses or application, we could apply a cost to.
And so you all got pretty lucky because that made my presentation very easy for today. And this is where we're going to go to the interesting stuff, at least from my point of view. A major traffic event happened yesterday. That said, it's not a terrible thing. These happen every day. It's just people don't have the tools to look at them. And so this is where we get to brag about, oh, we saw this first. So as I was saying before, the methods, the practices when it comes to deciding upon interconnection are dated. And they're mostly dated because the landscape has changed, but the tools haven't. And the metadata isn't in the network visibility data that people receive. So Kentik plans to fix that. And two of the biggest causes are CDNs and OTT. Back in the day, if you guys remember, when you were planning for network capacity, you had this ASN that was a content provider. It was very simple. I need more capacity towards Yahoo. Yeah, I can just bring up a pipe. Except it's much more complicated than that today. So I'm gonna talk a little bit about that, and I'm gonna explain to you how Kentik fixes that.
About the cost groups, before you move too far ahead, can you set up some sort of a notification? For example, a lot of SPs peer with, for example, Google or something like that in different locations. So if I all of a sudden, see my net flow go up to a certain degree, I want to be notified and be able to change the route policy to something else.
So your question is about getting notified whether traffic increases more than normal on a specific location.
For example, after a reroute event or something like that.
So this is something that the Insights engine would capture as part of capacity planning. And the drill downs from capacity planning and the click for those are fairly natural from the UI. So you'd get a notification that you're doing more traffic towards that ASN on that site, and then go from there. But the Insights engine is something that we've built as extremely modular and that we plan on evolving constantly. And so we could very much decide to, instead of saying you've got more capacity being consumed here, you could definitely say your price here is going to increase that much because of that traffic peak.
Right.
That's something we're entirely able to do. And so one of the things that I mentioned before is that CDNs are the new norm. Most, if not all, content providers rely on them. As a matter of fact, in the United States, if you look at an ISP, 90% of the content, and it's actually above that, towards the subscribers comes from a CDN or a variety of CDN. And so you can't really do without understanding which CDN your traffic is being consumed by, right? Now, the problem with CDNs is that they have a very variable geometry. What I mean by that is that each CDN delivers traffic over multiple different connectivity types. They have their own home ground network, distributed network, their network of caches everywhere. They also peer with you at public peering facilities. They will also peer with you privately, and most of the time these three together. But also they might have caches. If you're an ISP, they might have caches in your own network because they want to be as close as they can to the last mile to deliver better performance. And if you're an ISP, it's very interesting to have embedded caches in your network because traffic is not getting out of your network from outside of your network to your users, which is the part that's being billed to you. So you maintain your costs low and performance high. That's one of the key objectives here. And so one of the other things is that as I said, the era of the seamless network is over. And what I mean by that is that CDNs are each CDN is a very complex arrangement of infrastructure. And so the AS source destination ASN view that we had in the past is not valid anymore to understand interconnection practices towards these CDNs. There's really no KPIs in traditional network performance metrics to say which CDN it is. So you have to bake that logic in. And again, last mile caches are an actual reality and makes that picture even more complex. And so quite often, this is the full picture. It's a little bit overwhelming, so I'll give you a second to get familiar with it. But basically, you have an ISP. They may have an embedded cache on their own network. They might peer with the CDN providers on a peering fabric with a settlement-free interconnection or through a paid PNI. They also have a transit provider because you always need one to connect your subscriber to the internet. And at the other end of the spectrum is the content provider, who is in the back of all of that, where the CDN is the surrogate to convey their traffic into my ISP network. And so that's a fairly complex picture to describe. And so, let me get my slides right. So we're talking about, as I said, a fairly complex or noisy picture. You can't really benchmark CDNs, right? You can see the cost impact of one CDN's change of routing against another. You can't really see the performance differential to your subscribers based on a variety of dimension. And as I said, in the end, the important signal is dissolved in a ton of information that you either don't get or don't know what to do with. And as we've seen yesterday, and I'll talk to that, traffic events have become global. They're becoming quite the puzzle. Source and destination ASNs are not going to help you resolve these. There's a ton of time lost in investigation, and I'm going to show you that, at the expense of efficient resolution, right? And so, let me get on to the next slide. Wait. So here's the CDN Analytics Workflow here, accessible for the service provider section of the workflows. And so, this is mock data for a typical ISP, so tons of inbound, very little outbound. And we want to tell people that run infrastructure and network interesting and important things. Like in that case, 75% of the inbound traffic to the subscribers come from 5 CDNs. That's quite a bit. So you'd better have good relations with these guys. Only 8% of the traffic doesn't come from a CDN. So that's 92% of your traffic that comes from a CDN. You could easily improve connectivity to your users for content because in that case, 28% of your CDN traffic comes via transit. Transit means you pay for it. Transit means it's multiple hops away where it could be closer to you, right? And the last one is just a gut check. Kentik currently maps 52 CDNs out there. If you know more of them, let me know because we've worked quite a bit on this. Now, the Kentik engine behind CDN knows that some specific CDN offer embedded caches programs. Maybe you don't know about it, and so you'll see it. Netflix will offer you to embed caches in the last mile. Akamai will do so too. Google will do so too. Facebook will do so too. And so when you end up welcoming last mile caches into your own network, the first question you will always ask is, how much traffic is going to save me, right? How efficient is it? Like, if 10 of you come knocking at my door wanting to put caches in my network, how do I know you're better than the other? Well, you've got a pretty good explanation here. So you've got a single purpose content provider, Netflix. They can offload nearly 100% of your traffic. That's a pretty good deal, given that they're probably within 30 to 30-something% of your network traffic. And I'm only saying that because my previous gig was Netflix Open Connect. So I was the guy that offered these caches to the ISPs. Now, Akamai has a ton of content provider that it carries content for, and that content competes on your edge, which means that not all of very popular traffic gets carried by these caches in your network. So quite often it needs to go in the back scenes and fetch it. And so it has a little lesser offload. Now Google can do 72% and Facebook 37%. That's interesting info. Right now, you're only seeing traffic data, but soon enough, and this is a little dashboard that I cooked here, you will see that appear in the CDN workflow. Now what's interesting is that when you look at these CDNs, you want to know how they behave. And so what I did here, the first graph that you'll take a look at, tells you traffic that comes from 4 specific patterns. The one is comes from the outside to my subscribers. If you have embedded caches, you'd like it to come from the inside to your subscribers. It costs you less and it'd be more performant. You could look at traffic that comes from internal to your subscribers, the best. The one that costs you less and that is more performant to your subscribers, right? Then you could look at how caches feel, right? How much cache hits are the caches getting in my network? So it gives you an idea of the efficiency. And so the fun experiment here is to compare them against each other. So I've got that view on all of the CDN. And again, the drill downs, as we mentioned before, I can look at one and I'll get a ton of metadata. In that case, it's exclusively a commercial CDN, meaning it builds their services to content provider to carry content closer to the end user. But if I had another one, let's use, I don't know, let's use Google, because that's an interesting case. It's a commercial CDN, it's also a public cloud, and it's also a content provider. All of these. So that metadata is baked within the DNA of the Kentik platform. And associated with all of that, all the ASNs that are known and attached to this CDN. And so if I switch to another one, here, Akamai for instance, I can see something pretty interesting here. So I've got a kind of like a taxonomy of traffic that is associated with Akamai traffic, and I see that the lighter green part is traffic that comes from the cache, and the darker green part is traffic that comes from transit. And interestingly enough, on the peak towards the end, I see my embedded cache traffic that is stagnating, and my transit traffic that is increasing over the peak. And I see that everything that seems to go above 80 gigs is covered by transit. What that means, and just as a sniff test, is I think my caches in my network are overcrowded. It means I need to call Akamai and ask for new caches. That's kind of the kind of conclusions that we want the ISPs to be able to do with minimal effort. And so on that note, we're going to get to explain why that happened. No, I don't want to share that. And so this is when we talk about OTT. OTT is an over-the-top service. It's basically content service that you consume from outside of the network. This is not your IPTV service from your internet service provider. And so subscribers care about OTT services. That's all they care about. They care about the stuff that they use and how well it works. So bear in mind, if a subscriber is calling the hotline of his ISP, they're not network engineers. They're not going to say, oh, I got bad Akamai download rates, right? No, they're going to say Game of Thrones is buffering. They're going to say, I can't download the last Fortnite update. That's what they're going to say. And if you're an ISP, in a very competitive market, subscriber performance is definitely the name of the game. Subscriber performance is what will prevent your subscribers to migrate and to flee to another provider that has better performance if they're into Twitch and they can't watch Twitch at night because somehow you're not well interconnected enough with them. And so subscriber performance needs tracking. And it also needs tracking from a performance perspective, but also from a cost perspective, because performance in most cases equals cost. So what that means is that for an ISP to leverage good performance visibility, OTT level monitoring is an absolute requirement. Just knowing performance and download speeds from an ASN is not sufficient to get a clear view when an ISP calls the hotline or when you need to determine your interconnection policy. Now, bear in mind, it gets worse because OTT providers leverage all of the connectivity methods you can find out there. They might have their own network. They might use multiple CDNs. They might and will use multiple CDNs. They will also peer with you in an internet exchange, or directly, or through their transit provider. And worse than that, each OTT traffic event is completely unique, global, and completely impacting. For instance, let me give you a few examples, but CDNs carry multiple OTT services and providers. OTT providers leverage multiple CDNs, and there's really no, as it was the case for CDNs, there's no taxonomy or no attributes of network visibility data to tell you what service is being, everything is HTTP, and so there's no way to delineate what these are. And so Kentik found a solution to that. We're leveraging your DNS data, marrying it with flow, and telling you what happens. And so this is the most common thing I've heard in a coffee break room of an ISP, of an internet service provider. Hey, our subscribers are complaining about the performance of that video service. Do we peer with them? Tumbleweeds? Well, that's the most common picture that people are looking at. There's this video service provider, comes to me through several POPs, through a variety of connectivity types, through a variety of connectivity providers, through a variety of CDNs. And you need to be able to have that very clear picture in mind if you're going to support an efficient hotline, or if you're going to track and monitor performance and cost towards your users. But because bear in mind, every transit free PNI embedded cache IX is a different price. Comes with a different performance too. But it gets worse, and this is where it's going to get interesting, is nowadays, major content events happen across a variety of content providers at the same time. And I'm going to tell a little bit more about that. So this happened yesterday. So yesterday, Akamai was telling that they hit a new peak of traffic, 140 terabits per second. And tons of people were scratching their heads. What was that? And so this guy here posted that he had an interesting network problem, looking at his ports going red, no idea what it was, realized it was Call of Duty. The thing is, a couple of days before, I was looking at the event, and I was like, yep, I know what this is, and I'll show you how I did that. And then this is from the CTO of DKIX, the famous internet exchange in Germany, that was noticing that huge peak of traffic in one chat. When I talked to him and asked him, do you know what it was? Crickets. And I told him, oh, it's very easy. Let me show you that. And so this is where I'm going to show you how the OTT module in Kentik is going to maybe save your life. At least going to make you look smart. And so I'm going into the workflow that's called OTT service tracking. So a few cool things. We're very transparent about how much our engine is able to detect and classify in terms of OTT services. And we see that for this ISP here, 89% of their traffic is being successfully classified. 6% we determine the provider, but not the specific service. 5% is pending, means our engine is learning, and so these 5% are going to be replaced by less percent as we learn, and 0% is unclassified. Now here's the thing, with natively identifying categories, because I mentioned that content events were global, meaning there's a gaming event. Look at that here. That's a pretty nice bump right here. And so that's interesting to look at because there may or may not be more than one provider involved in there, right? And so I'm going to click through that. And here it is. I may be able to zoom that in. Can you see a little bit better here? I see a huge bump on Xbox Live. I see a huge bump on PlayStation, and I see a huge bump on Blizzard. These are 3 separate providers. All of them have their own networks. All of them leverage a different set of CDN providers. But that gives me a very important piece of information. Right now, the only game that gets distributed through Blizzard's Battle.net, through Xbox Live and PlayStation, that's Call of Duty. It took me barely 2 minutes to figure out. And so when I see that, I can look at my traffic and how it's composed, and I can make the right decision on which CDN that traffic is being carried from. Like, if I look at Xbox Live here, I'm going to know all the sites that it comes from. I'm going to know what type of connectivity I have towards this OTT service, right? And so I'm going to see that it's most of the time it comes from embedded caches, but when something big happens, I see a lot of it going through transit and PNI. So overflowing from one to another, that has a performance impact. I can look at the source CDNs involved, right? Who is delivering that Call of Duty stuff on the Xbox Live? And here it goes. I can see that there's a bit of Edgecast, there's a bit of Akamai, there's a bit of StackPath, a bit of Level 3. And I have all my answers here right at hand.
And it's by combining DNS data with the traffic that lets us do that. You can find CDNs without that, but to see what someone's doing within a CDN, we need the DNS data also.
And so conversely, I could look at a CDN. That's a very interesting thing to look at, actually.
We have just a couple minutes, Greg.
Perfect. I can look at a specific CDN. And I can look at all the traffic that they're sending me. So I'm just going to show fully classified and provider-only classified. And I can look at a CDN and see in which proportion they're delivering every single of the OTTs that they have on my network. And I can also see the performance for that. And so we believe that this is how we will help make leverage better intelligence to make better peering decisions and much more instrumented peering and interconnection decisions.